Hi studying engineers, welcome back to the another video. In this video we are going to discuss about stress. Do vessels fail due to pressure or stress? It's simple, right? If we increase the pressure, it's going to fail. If the vessel is not indent to that pressure, it's going to fail. But is it fail due to the pressure? No, it's not failing due to the pressure. It is failing due to the stress. We will discuss further. Understanding what is stress. Stress is simple force per unit area. I know you are a bit confused because the same explanation we have provided for the previous video for the pressure is equal to force per unit area. Stress is equal to force per unit area. What is the difference between pressure and stress? It's simple. Pressure affects the vessel externally or internally. I mean, pressure affects the vessel on the vessel surface. If the pressure is internal pressure, the pressure is going to affect the inner surface of the vessel, or if the pressure is external pressure, the vessel is going to be affected by externally only on the surface. But stress doesn't happen like that. Stress happens inside the material. The material has particular thickness, right? Inside the material, stress is going to be happened. Using this image, you can able to understand that how the stress going to affect the particular material. Okay, this is the sample specimen we are going to provide for the tensile strength. To check a particular material tensile strength, we are going to produce sample similar kind of this, and during tensile strength what we are going to do is we are going to pull the material outwards. During that time stress will happen in this particular region and the length will increase and dia will decrease due to the Poisson's effect, because the volume has to be maintained. This is how the material responds to the stress. Okay, now we will differentiate pressure and stress. What is pressure? Pressure is a applied force that we will provide for the particular equipment, and the pressure will directly affect the outward surface of the material. It doesn't affect the inside surface of the material. Maybe it affects the internal surface or external surface. That is due to the internal pressure or external pressure. But what is stress? Stress is the response of the particular pressure. If the material is going to experience the pressure, then there will be some stress. Due to the pressure, stress creates. Stress is the internal response, the steel fighting back to hold its shape together. The vessel does not fail directly due to the pressure. The vessel fails due to excessive stress in the particular material. Okay, which seam will fail first? Okay, this is the typical pressure vessel you can able to see anywhere. It has a circular seam, it has a long seam. If the pressure vessel is made of pipe and end caps, there must be only surseams. But if it is made of plates, then there must be a long seam and there must be a surseam. Which seam fails due to the stress? The failure location completely depends on stress level applied to each weld. Now we will discuss about the hoop stress. Hoop stress, otherwise we call it as circumferential stress. Hoop stress is the highest stress magnitude in the cylindrical pressure vessel. In the formula you can able to see that PD by 2T, a simple academic formula. This tends to tear the cylinder apart along the longitudinal seam. The vessel will experience a hoop stress similar to this image, similar to this arrows. The vessel will experience a hoop stress. Due to this direction, it will directly affect the long seam belts. And this is very critical one in the pressure vessel, because there are almost three kind of stresses. One is hoop stress, and another one is longitudinal stress, and another one is radial stress. So comparing all the three stress, the most dangerous and most high stress one is hoop stress. Okay, we will go for longitudinal stress. Actually, longitudinal stress is simply in this formula you can able to see that comparing with hoop stress and the longitudinal stress, it is almost half the time of hoop stress. You can able to see that PD by 4T. It is almost half, so it's not going to affect the pressure vessels directly, but in some places it will affect pressure vessels directly, and it will affect the circumferential seams. As I already told, hoop stress is most dangerous one. It is 2 times of longitudinal stress. The longitudinal seam is most critical joint in the pressure vessel. If the cylindrical vessel is over pressured, the failure will likely start in the longitudinal seam. That means the failure will happen due to the hoop stress. And in pressure vessel, we can able to split the vessel into two categories. One is thick vessel and one is thin vessel. For thin walled vessel, the thickness will be less than 10 times of radius. For the thick walled vessel, the thickness will be greater than 10 times of its radius. For the thin walled vessel, the stress will be uniform across the thickness, but for the thick walled vessel, it is not uniform across the thickness. For the thin walled vessels, we can able to design the vessel using ASME section 8 division 1, but for the thick walled vessels, it requires Lamis equation. We have to go with FPA or either with complicated calculations, but normally if the thickness is below the 10% of the radius, we will calculate using ASME section in division 1. And finally, radial stress. Radial stress is simple, it's directly applied pressure. That means the pressure is a stress. Normally the radial stress doesn't affect the thickness at all, it doesn't govern the thickness at all. We don't need to calculate the radial stress, but for the technical reasons we have to calculate the radial stresses. Where the radial stress will affect means, the radial stresses will affect when it is combined, with another stresses, then we have to use the radial stress. Okay, we are closing the video. Next video we will discuss about the allowable stresses actually. But before going to the allowable stress, I had some plans to discuss about broad categories of stress. Before starting the vessel design, you have to know there are different categories of stress, but at this stage it is bit complicated to explain those things, so we will continue next video with allowable stress. But one day we will surely discuss about the broad categories of stress. What are all the primary stress, secondary stress, what are all the effects due to the primary stress, what are all effects to the secondary stress, those kind of things we will discuss in the future videos. In the next video we will discuss about the allowable stress and how allowable stress impact our design. Those things we will discuss in the next video. Until then, tada, bye bye.